Imagine you're taking a sip of cool, refreshing spring water. Suddenly, your throat isn't just wet, it's burning. Every cell in your body feels like it's being poked by a billion microscopic needles. Outside, the ocean doesn't wave. It boils with a deafening roar of escaping gas. This isn't a dream. This is the moment physics decided to play a cruel joke and turn every single liquid on Earth into a carbonated solution. Within seconds, the planet becomes a giant, uncapped bottle of soda. And humanity is about to learn exactly how much pressure the universe can handle before it snaps. The change is instantaneous. In physics, we call this a phase transition on steroids. Every molecule of H2O is now forced to hold dissolved CO2 at a saturation level that defies common sense. The first thing you'd notice isn't the fizz, it's the sound. A global, bone-chilling hiss that drowns out everything else. Think about your morning coffee. It's no longer a beverage, it's a volatile chemical hazard. The sudden release of gas causes liquids to expand by nearly 1,000 times their volume. Your blood? It's now 90% bubbles. Imagine the pressure of 3 Eiffel Towers pressing down on your thumb. That's the kind of internal force we're talking about as gas tries to escape your veins. You wouldn't just feel bloated. Your circulatory system would literally whistle as gas escapes through every available pore. The oceans are the real nightmare. Earth's seas contain 1.3 billion cubic kilometers of liquid. Suddenly, they are all supersaturated. The surface doesn't just rise, it explodes upward in a white, frothy mist of carbonic acid. Coastal cities aren't flooded by waves. They are buried under miles of suffocating foam. Ships don't sink, they fall. Because gas-filled water is significantly less dense than liquid water, every vessel on the ocean loses its buoyancy instantly, dropping into the abyss like a stone falling through a cloud. Let's talk about your body. You are 70% water. Or you were. Now you are a walking, screaming can of warm Sprite. In medicine, we call gas bubbles in the blood embolisms. In this scenario, your entire vascular system is one giant embolism. Your heart is a pump designed for liquids, not foam. Trying to pump carbonated blood is like trying to use a water pistol to shoot whipped cream. It's inefficient, messy, and the mechanism will seize up in seconds. Your brain, the most oxygen-hungry organ you own, is suddenly starved. As the CO2 bubbles expand, they trigger the suffocation alarm in your brainstem. You would feel an overwhelming primal panic, the air hunger, even while breathing deeply. But here's the absurd reality. You wouldn't just be gasping, you'd be burping, constantly. The gas in your stomach, your cells, and your spinal fluid needs out. It's not a polite "excuse me" at dinner. It's a violent structural failure of human tissue. If you manage to survive the first minute, your eyes would look like shaken-up snow globes. The vitreous humor, the gel inside your eye, would fizz, turning your vision into a blur of sparkling static. Forget the human body for a second. Look at the world we built. Modern civilization runs on pipes. Water mains, cooling systems for nuclear reactors, sewage lines. All of them are designed for incompressible liquids. Carbonated water is a different beast. As the gas releases, pressure in city pipes skyrockets. We're talking about geysers of sewage punching through asphalt like armor-piercing rounds. Every toilet in the world becomes a reverse pressure fountain, spraying acidic foam into bathrooms at supersonic speeds. Your car doesn't just stop, it might explode. Most engines use liquid coolant. When that coolant turns into a gas-releasing frenzy, the pressure blows the radiator caps off like champagne corks. But the real kicker? Lubrication. Oil is a liquid. If the oil in your engine starts to fizz, it loses its viscosity. Metal grinds against metal. Within minutes of the great carbonation, every running engine on Earth seizes, welds itself shut, or bursts into flames. Nuclear power plants would face a terrifying crisis. They rely on steady water flow to keep the core from turning into a puddle of radioactive lava. With the water turning into a turbulent, bubbly mess, the pumps cavitate. They spin uselessly in gas pockets. It's a global Chernobyl scenario happening simultaneously in every cooling pond on the planet. Where does all that CO2 go? Up. The sheer volume of gas released from the oceans would double, triple, and then decuple the atmospheric pressure. You wouldn't just be breathing air. You'd be breathing a thick, acidic soup of carbon dioxide. The temperature would plummet before it skyrocketed. The process of gas escaping liquid, evaporative cooling, would suck the heat out of the oceans. The world would feel a sudden, freezing chill as the fizzing consumes energy. But don't get your hopes up for a new ice age. Once the CO2 settles into the atmosphere, the greenhouse effect kicks in with a vengeance. We aren't talking about a 2-degree rise over a century. We're talking about Venus-style heat within weeks. And the rain? The water cycle is ruined. When it rains, it won't be droplets. It will be a caustic, carbonated drizzle that eats away at limestone buildings and statues. Imagine the Great Sphinx or the Parthenon simply dissolving like a giant Alka-Seltzer tablet. Societies would collapse before the first news report could even be aired. Communication requires power, and power plants need cooling water. Within 10 minutes, the internet goes dark. Within 20, the power grid is a memory. The economic value of fresh water disappears because fresh water no longer exists. The only survivors might be those in pressurized deep-sea habitats or high-altitude labs where the pressure differential is slightly more manageable. But even they are just delaying the inevitable. The global economy becomes a barter system based on who has the most functional gas masks. Eventually, the Earth reaches a new equilibrium. The oceans stop boiling once the atmospheric pressure becomes so high that it forces the gas back into the liquid. The planet is now a quiet, hot, pressurized greenhouse. Life, in some form, might survive. Deep-sea extremophils that already live under crushing pressure might not even notice the change. To them, the great fizzing above is just a distant rumble. In the end, we've always treated water as the silent, stable foundation of life. We take its stillness for granted. But if the universe decided to add a little sparkle to our existence, we'd realize very quickly that life is a fragile miracle held together by the very specific behavior of a few simple molecules. We are just a temporary arrangement of atoms, trying very hard not to turn into a fountain of bubbles. So, next time you open a soda, listen to that hiss. It's the sound of a world that didn't end yet.